Welcome to the course of Polymer Reaction Engineering. And before we start this course and we introduce our polymerization processes, let's have a brief look about the polymers. Now, polymer occupies a very vital place in our day-to-day life. Now, if you start your day right from toothbrushing to if you go to the bed, everywhere you will see there are a variety of a spectrum of polymeric products. Now, if you are using day-to-day affair, you will see that they are having various kind of approaches in the polymeric application, like flexible sheet to the bumpers of cars, etc. There you require various kind of mechanical, chemical and thermal properties. Everywhere you go to the either PET bottle, whether you go for any kind of a packaging material, whether you go for any kind of a clothing, etc. Everywhere you will find there are a galaxy of a polymeric products. Now, when we talk about different kind of a polymeric products, then the things come into mind that what is the protocol for the development of such kind of a product. Second thing is that what is the science behind these kind of a polymeric product, because if you see that the flexibility in the polymeric sheet, or if you go for the impact property of a car bumper or any kind of a thing which is require any thermal, mechanical and chemical properties, you see that the protocol for the development of such kind of a variety of polymeric product is entirely different. Now, as we go into the polymerization process, every process attributes to two type of a thing. One is related to the process and second is related to the operation. Now, remember, operation always supported by the process. It is just like that if you are having two chemical products with two chemical reactants with you, and if you wish to develop any kind of product through it, then you need to look into the various issues related to this one. I am giving a broad spectrum of ammonia synthesis example, that like N2 plus H2 gives you NH3. Now, you see that if you are having an engineering background or a science background, this is an exothermic reaction. And it is not so easy to convert the nitrogen and hydrogen into ammonia, because it is an exothermic reaction. It requires so many type of temperature and pressure control protocols, etc. And sometimes if you got the product, then you require some specific applications of that particular product. So, you require some specific characterization of that particular product. The same way it happens in the polymerization processes. Polymerization processes, because of the variety of a spectrum and variety of application, you require different type of polymerization steps, you require different type of things need to be carried out. So, the basic theme, because whenever we are having different kind of reactants, when we are having different kind of a product demand, in that case it offers a wide spectrum and wide knowledge of reaction engineering concept. Sometimes reaction may be endothermic, sometimes reaction may be exothermic, sometimes you require certain higher molecular weight components, sometimes you may require any kind of a different product for the specific use. I am giving you a broad brief knowledge about polyethylene. Polyethylene sheets are always there. If you go for linear polymers, then you can develop the sheets, and if you go for some mechanical or stiff type of a polymer, then high density polyethylene, etc., they offer wide spectrum. Raw material is same, but the application point of view, it is entirely different. So, based on various kind of application, based on various kind of specialty demands, there is a wide variety of a polymerization product. So, based on this particular thing into our mind, first couple of lectures are attributed to the what is polymer and what is the history of polymerization. Since it offers a wide variety, then every scientist across globe, they try to develop their protocols, they try to develop various things, like if you take the example of a toothbrush, there are two different type of polymers, one through which you for the gripping, another one is for the brushing. So, the process for the development of these two things are entirely different, and another thing offers that how you infuse them. so that it may have a compatibility, it may have a various application. Now, if you go for further detail, then definitely you require certain specific things need to be carried out for those toothbrush applications. Like gripping, you require certain light things, and for brushing, etc., you need to have some abrasion issues, etc. So, based on this particular approach, you need to learn about that what kind of a protocol we need to adopt for different type of or development of a different type of polymeric products. So, based on this particular thing, we are just going to have an outline that what we are going to learn in this particular lecture, that is introduction to the polymerization process. Then we will discuss about the various kind of a polymers or the classification of the polymer, because when we try to develop a protocol for any kind of a polymerization process, then we need to know that how we can classify all those polymers, and based on this particular information we can develop our protocol. Now, see, one thing is that if we talk about the classification issues, there are several methodologies given by various scientists, like based on source of polymer. There are natural polymers. Nature gives me a number of polymers, like if you take the example of a cotton, etc. We will discuss this thing in due course of a time. These are the natural polymers. Then we try to develop the synthetic polymers based on our own use. Then another classification can be given based on the behavior towards heat. This is a very common thing, thermoplastic polymers and thermosetting polymers. Now, the more scientific way in which we can classify the polymers are linear, branched and cross-linked polymer. We will discuss this thing in due course of a time. Now, before we start, as I told you in a couple of minutes ago that polymer occupies a vital spectrum in our day-to-day life, then issue arises that what are those polymers? Now, this term polymer, this can be defined by as a poly means many and mers means apart. So, it is a building block of different type of monomeric substance. Now, these monomeric substance may be like a brick-like structure, and you need to join those monomers with the help of a suitable technique or suitable process to build the entire spectrum. Now, usually the polymers, they are large molecules having higher molecular weight and a very complex in structure, formed by linking a very large number of small molecules or monomer together. They have a different chemical structures that is purely based on the requirement. Physical properties, I told you that you may have a plastic sheet or a polymeric sheets. They may offer a very good spectrum of flexibility to the car bumpers, where you may have impact resistance, etc. Similarly, the physical properties, mechanical properties, thermal stabilities, you may have various kind of packaging material in which you may see that there is a thermal stability, so that there may be a minimum interaction between the inside the material and outside the atmosphere. So, these kind of various applications can be attributed to the polymeric system. Now, these polymers exist in many forms and a number due to the large number of types of atoms or molecules present in their molecular structure. If you see that the automotive tires, they are big molecules, but they are having the sulfur present in during the vulcanization process to offer many kind of chemical, thermal and mechanical properties. Now, the smallest molecule which replicates itself many number of times to form the giant molecule, this is termed as monomer. In the previous slide, I refer that these are the building blocks of the polymeric substance. So, such small molecules which combine to a big molecule may be one of the more chemical compound. Now, trust me, this is the genesis of your polymer reaction engineering, that how you can build up those empire of a polymer with the help of a small monomer units. What are the different kind of a chemical process you need to adopt through which you can get your desired properties? what kind of different things you need to, or what kind of a different additives you need to add in those monomers when they propagate itself to form a polymer. That is again a very good type of engineering, so that you can form a polymer which offers the desired properties which you are looking for. So, in nutshell, we can say that monomers are the raw material to form a polymer, and the process of linking of those monomers may be via covalent bond, maybe by the van der Waals bonds, etc., to form such a large molecule. They are called the polymerization, or the process of polymerization. Now, when we talk about this process of polymerization, several things come into mind. That is it so easy to brick to form this kind of a thing? Just if you go to the construction industry, there are small bricks. Now there is a set process that you require some cementing material through which you can join all those bricks to build either room or whatever house or whatever building you would like to have. And then you, because the size of the brick, then the cementing material, one thing is essential, that always they offer the choices that what kind of a properties you are looking for that particular building. So, in that case similar things they are offering, because the polymers, the monomers, they are just building blocks or bricks, and the process through which you are joining all those things, they are called the process of polymerization. So, when we talk about the high molecular weight compound, now their weight can be ranges from hundreds to the million units, that is purely based on the requirement. Now, when we talk about the million units, then they offer a large molecular weights. It is just like that if you compare one brick of your building unit, and if you try to imagine that if you are building a room, then you can calculate the cumulative weight of all those bricks. Now, when we talk about this polymerization process, it usually offers three different steps. One is the initiation, second one is the propagation, and third one is termination. The reason for these three steps is that you must have any process through which you can trigger your process, because usually these monomeric units are in situ, they are having some inert properties. So, whenever you talk about the initiation of the process, something you require to trigger, and once they initiate the process, that is called the propagation, then they try to join different monomers all together and they develop. Then at you require one particular point where you need to truncate that particular reaction, otherwise they may combine together to form different type of blocks. Now see, I am just giving you, suppose I am talking about this P1. This P1 is a monomer. Now, if you are having a reaction mass where all monomers P1, P1 and P1 etc. Now, if you start the things, then P1 may combine with P1 to give you P2. Now, in the next step, this P2 may combine either with P1 to give you P3, or this P2 may combine this P2 to give you P4. Now, this is why I am emphasizing that we require the truncating step. We will discuss this thing in detail in subsequent lectures. Now, this P4, trust me, they may have a variety of choices. It may combine with the P1 to give P5. Similarly, this P4 may combine with P2 to give P6 and like this. So, if you see that this particular thing offers a wide spectrum, and you will not be able to control the things unless otherwise all the things are being consumed. So, that is why the truncation process or the termination process is required. Now, the question arises that how we can see and how we can initiate the things, because sometimes you may have a monomer which is having you can say the inert approach, how you can trigger it to be to get initiated with the help. No doubt there are certain specific requirement of a temperature and a pressure and other catalyst, But for polymerization to occur, it is required that these small monomers or small molecules, they must have some reactive functional group or unsaturated bond, double bond or triple bond, which can join to provide the necessary linkage between these repeated units to form the polymerization process. I will give you an example of polymerization of ethylene to polyethylene in the due course of time. Now, I am giving the example of polymerization of say vinyl monomer into forming the polyvinyl thing. Now, here see, this is the basic structure of vinyl monomer. Now, if we perform the polymerization process, you will see that because it is having this double bond, it offers an opportunity to be get linked with other monomers of either same category, or if you are having adopting any kind of a special process, you can link or graft some other monomer to it. So, we go for the polymerization process. Now, here you see that this double bond is linked with other monomers to give you the this is the now this is sometimes in literature it is referred as repeating unit. So, this vinyl monomer get polymerized to give you the polyvinyl. So, based on this particular approach, up till now we understand that what we require. First thing is that we require that what kind of the desired properties we are looking for. We are having our monomer with us. Then to trigger the reaction, we require certain functional group to be added to this particular system. Now, before we go into the details of this kind of a polymerization process, initiation, propagation, termination, etc., let us have a look about the classification of polymer. As I told you that this classification of polymer offers a very good information through which you can assess the various properties attributed to your final product and what kind of process you require to have your polymerization process. So, first thing, as I discussed in the very first slide of this particular lecture, is that based on the source of polymer, that is on the basis of their origin, these polymer can be classified as either synthetic or natural. Now, natural, why natural? Now, see, if you see the photograph, nature offers various kind of a polymeric product to our day-to-day affair or day-to-day life. So, natural polymers, they can be found naturally and can be extracted for the commercial use. Usually, they are termed as water-based compounds. And these examples, if you say that all kind of a silk is a natural polymer, wool is a natural polymer, cotton, natural rubber, living DNA, cellulose, proteins from plant, animal. Now, these things are you can say the natural polymers, and if you see that like if you take the example of a natural rubber, it offers a very good spectrum of future kind of a development like rubber tires, etc. So, you can see these type of things are available in your day-to-day affair, readily available. Now, why we are talking about this natural polymers? Because if you see that silk at the start, at the outset, the silk was termed as a natural polymer, but it was giving, I mean, the people got an idea that because silk is a very useful product. So, people thought that if we are having any kind of a product which is having the properties like silk, can we develop in laboratory? Can we develop the things in the industrial scale? Similarly, wool. Similarly, if you see the cotton, similarly if you see the natural rubber. So, all kind of things are, you can say, the base material or thought process or school of thought process was the natural polymer. and it gives an impetus to the scientists that they try to develop, because they gives you the usefulness to our day to day life. And that is why, because to meet out the requirement of growing population and to offer more and more stability to the product, people thought to change the several polymerization process so that they can achieve the desired properties with respect to our day to day affair in different processes, and that is the root cause of development of various polymerization process. Now, based on this particular thought process, people thought about the synthetic polymers. Now, as the name implicates that these the polymers synthesized from lower molecular weight compound obtained from either polymer products or a natural feedstock, they are termed as a synthetic polymer. And if you see that these are some of the products available as on date which are attributed to the synthetic polymers. Right. So, see, based on the requirement, based on the things you are available with you as a raw material, you can develop all those things. Now, see, World War II, they offers a very good, I mean, the people like German, Americans, they just intended themselves towards the development of these products to carry out the meat requirement of those warriors, those army people, etc. So, after World War II, various advancement in the science and technology happened. Synthetic polymers, they got more and more impetus, more and more efficacy in our day to day affair, and that is why still this development process is going on. If you see, I mean, if you are say 15, 20-year-old or 25-year-old, you will see that there are various kind of development in the polymeric products are going on, like from bucket to the tubs to the even if you see that nowadays we are talking about the personal protective equipments. So, everywhere you will find, and now we are just one step ahead, that is we are talking about the degradable polymers or depolymerization or biodegradable polymers. So, this particular concept offers a very wide spectrum for the future entrepreneurs as well as the future researchers. Now, back to the synthetic polymer. Since that time, we were talking about the World War II, the production of polymers with a different physical, chemical, morphological and structural properties are advancing day by day, as I discussed, because for almost say 100 years, everyone, those who involved in the system of a polymers, they are engaged themselves to develop a new protocol which are less energy consuming, they are energy efficient, eco-friendly, etc. So, because see, you can't change the process of a natural polymer, but you are having various opportunities in the development of a synthetic polymer. So, the reason being for the fact that synthetic polymers can be modified based on the application, based on the requirement. It can be formulated on very dry basis, which opens a very broad domain to the application of various kind of polymers. It can be formulated either on a dry basis, it can be formulated on either on the wet basis, etc. So, you are having various routes, you are having a various developed science and technology process available. So, you can develop a number of polymers with the synthetic polymer routes. There are other factors which are involved in the development of synthetic polymers, that people are demanding the lightweight materials, they are demanding the good flexibility, they are demanding the resistance to chemical, or to be more precise, the resistance to the environment, so that they can be used in the packaging material, they can be used for storing the things. By this way, they are not only supplement to the development of synthetic polymer, but also they are serving to the other industries like food industries, like other chemical industries through by providing the barrier to the atmosphere, so that their shelf life or life cycle assessment can be improvised. Even they can serve as electric or heat insulators. If you see the wires over which there are PVC insulation or insulating materials, a different kind of a color codings are there. So, what you require that your product or your whatever things you are using will have more and more shelf life. By this way, by this approach, because ultimately it will be the cost efficient. So, it offers a various spectrum on the development protocol of the synthetic polymers. Now, these polymers cover a wide range of applications like soft packaging, I told you, to the fibrous materials, to the stronger than steel and allowed the simple process. So, basically as I told you that their raw material for those synthetic polymers are petroleum oil, which can be synthesized to obtain in the various desired products. I am giving you a brief gist of these synthetic polymers, although this list is not you can say the exhaustive. There are n number of products, but just to synchronize the things into your mind, that there are various examples like nylon 6, nylon 66, HDPE, LDPE, LLDPE, polyesters, basically used for the textile industries, and now we are always intended to have some blended fibers for our textile products like shirts, trousers, etc. Polyethylenes for the packaging industries, resin, epoxy alkyd resins, formaldehyde, polyurethanes. Even you are using those water purifiers in your household applications, they offer the various ion exchange resins. The base material for those ion exchange resins are polymeric products. So, you can see there is a wide spectrum of these synthetic polymers. Other examples are PTFE, this is remembered as non-sticky utensils, etc. You are having the coating to the utensil surfaces, they are usually a PTFE coatings. Now, to understand difference between the natural and the synthetic polymers, we can always take the example of network polymers, vulcanized rubber. Best example of vulcanized rubber is your automotive tires, etc. So, these are the things, various kind of examples attributed to the synthetic polymers. Now, sometimes people talk about that, okay, these are the things like natural polymer and the synthetic polymers, go away all those things. The oldest way is to classify those polymers was that purely based on the their response towards heat. Now, on the basis of polymers which are having the response towards heat, we can divide these polymers into either thermosetting and thermoplastic one. Now, thermoplastic polymers, those either melt on heating and solidify on cooling, and heating and cooling cycle can be replicated to several times without affecting the properties of the polymer. They are clubbed under the head of thermoplastic polymers. Now, again, this particular approach offers a very good property that you can recycle the polymers, because nowadays these plastic materials or polymeric materials, they are, again, people are talking about that they are danger to the human system or environmental system. So, if we utilize this particular property, then we can recycle those polymers to several times, and if they are not affecting this recycling approach is not affecting to the property of polymer, it offers a very good flexibility to the system. Now, as I told you that these thermoplastic polymers, they offers a wide spectrum towards the heat. Now, this particular properties can be utilized to develop different type of products which are listed over here. So, we can fabricate the things, many type of typical applications like tubs, buckets, etc. Even the automotive parts, if you enter into your car and you will see that the dashboard, other things, some of the things are manufactured with the help of a thermoplastic polymers. So, they offers a very wide spectrum towards the product development. Now, this particular thing is sometimes can say the disadvantage, yes, because frequent heating and frequent melting sometimes may offer the breakage of the chain in that polymers, and by the repeated recycling process sometimes these polymers may not offer such properties which you are looking for. So, by this way we can have other examples of these thermoplastic polymers like HDPE, LDPE, polyvinyl chloride, polyethylene terephthalate, polypropylene, polystyrene, etc. So, they offer a wide spectrum, and we can have a different type of applications which we will discuss in this particular lecture as well as in the subsequent lecture. Like they are these HDPE, they are having the application in industrial wrapping, film, pipe, containers, toys, housewares, etc. So, by this way we will continue this particular classification in the subsequent lecture, and we will discuss about the various application and nitty-gritties of these thermoplastic polymers as well as the thermoset polymers, and we will continue the classification scheme in the next lecture. Thank you very much.